Hello, core training participants. Welcome to Trees 101. This is the second module of core training, where we will talk about some basic tree biology. My name is Pam Zipsey. I'm the outreach coordinator for the urban forestry program at Rutgers. I'm very happy to be participating in core training with you again this year, and I'm really looking forward to getting to know you through the discussion boards, and I'm hopeful that you will be posting throughout this 3-week short course. I also am really looking forward to our discussions at the live sessions over Zoom, which will be on March 22nd and March 29th. But for now, let's just get started. And we will start with defining a tree. So what is a tree? Somebody give me an answer. I'm just kidding. I know you can't answer. Of course, we all know what a tree is, but I think it can become difficult when we try to actually write out or think out a definition of a tree. But it's important that we can do that. So here's just a dictionary definition of a tree. Woody perennial plant, typically having a single stem. Notice it says typically, not always. Growing to considerable height. Considerable could be a lot of things, pretty subjective, and bearing lateral branches at some distance from the ground. So that's a good definition. I feel like it probably fits all of our mental image of what a tree is, what a tree looks like, but it doesn't really tell us a lot in terms of, specifics for a definition, and that can be really important to iron out. For example, if you're doing a tree inventory, so you know how to deal with a multi-stem tree, or how to distinguish between a large shrub and a small tree, or at what size you're going to start counting trees that might be very small growing up in a park. So those are important things to define for your program. But this module is more about tree biology. So we'll keep going with this general definition. And maybe your tree, the tree in your mind, looks like the one on the slide. Maybe it's a slightly different shape tree or in a different location. Maybe it's a conifer instead of a deciduous tree, an evergreen instead of one that drops its leaves in the fall. But in any of those cases, I think it fits this definition. But I would encourage you to also think about a tree in terms of their functional definition, right? So we've been talking so far about what a tree looks like, really, but how about thinking about a tree in terms of the way that it functions? So could we define a tree as a large water pump facilitating moisture exchange for energy conversion and food production? So if we think about that, I feel like that is a good start toward a basic functional definition of what the tree is doing. And that will help us, thinking about the functional definition, will help us to think about what it is that a tree is doing that produces those environmental services benefits that are behind a lot of our reasons for wanting to plant more trees in our community, and that we should be thinking about for making the case to invest in the maintenance, the ongoing care of those trees that we invest in for the benefit of our communities. So in this functional definition, we're talking about the process of photosynthesis. I couldn't find a diagram for photosynthesis that had everything that I wanted to talk about, so I drew my own. And I want to apologize for the poor quality drawings that you are about to experience, but we do have here a tree and the sun and a compass over here just to indicate that in this drawing the sun is to the east of the tree, and we'll go from there. So photosynthesis takes place in the leaves, and it involves carbon dioxide that is absorbed from the air into the leaf through tiny openings in the leaf, and water that is absorbed from the soil up through the roots and into the leaves for use in photosynthesis. This is the basic formula for photosynthesis. So we have carbon dioxide from the air being absorbed into the leaf, and we have water from the soil being absorbed through the roots and up the stem into the leaf where photosynthesis takes place. And in photosynthesis, the energy from the sun is used to convert the carbon dioxide and water into sugar and oxygen. And those sugars are used by the tree to grow the crown, and to grow the stem, and then some are also stored for later use. So an example of that would be deciduous trees that drop their leaves in the fall. So if photosynthesis is how the tree makes its food and it takes place in the leaves, then how does the tree have energy to leaf out in the spring after winter when there are no leaves on the tree? Well, it uses the energy that it has stored from the year before. And in addition to the sugars that are created through photosynthesis, there is also this byproduct of oxygen that is then released back into the atmosphere. For a tree to be healthy, it must be able to carry out photosynthesis. That's how it makes its food. And so a tree that is growing well and photosynthesizing at a good rate will provide more environmental services benefits than an unhealthy tree. A large tree will provide more benefits than a small tree, but it's that photosynthesis that is driving those environmental services. So keeping a tree healthy is not only going to be good for the tree, but it's going to be good for us in terms of the benefits that we derive from that tree. I want to talk about those benefits of trees and how they relate to how a tree functions. How can we tie those benefits to the rate of photosynthesis and the health of the tree? And one of those benefits that gets a lot of attention these days is carbon storage and carbon sequestration, right? Planting trees for carbon management to help battle climate change. And so the way that that works is that carbon in the form of carbon dioxide is moved out of the atmosphere by being absorbed into the leaf, and then through the process of photosynthesis is converted into the sugars that are used for growth and storage within the tree. So that carbon is then used to build the tree and therefore is locked up in this long-term storage. Sequestration is usually referred to as a rate and is tied to the annual growth of a tree. So the rate of sequestration has to do with the speed at which the tree is growing, so is then tied to the success of the photosynthetic rate of the tree, right? So if the tree is healthy and is growing quickly, is photosynthesizing a lot of carbon out of the atmosphere, that's going to be a high rate of sequestration. And then the annual carbon sequestered is eventually transferred into long-term storage as the tree grows. So that's how carbon storage and sequestration works, and that's how it is tied to the health of the tree and the ability of the tree to photosynthesize. Another important environmental service of trees that we are talking a lot about lately is trees for stormwater management. So we know that water is used in photosynthesis, and if a tree is growing quickly, is healthy, is doing a lot of photosynthesis, it's going to be drawing a lot of water up out of the soil and therefore creating more room within that pore space in the soil to hold more water. Trees are also releasing water vapor into the atmosphere through transpiration. So water is being used in photosynthesis and is also being released out of the crown, out of the leaves, and in addition to drawing water up out of the soil through that process of transpiration, it's also cooling the surrounding area. So that's an additional benefit. Another way that trees help with stormwater management is by simply intercepting the raindrops as they fall. We're experiencing more frequent and more severe storms, and trees, by simply intercepting the rain and slowing it down, can allow for more time for the water to infiltrate into the soil, but will also help to lessen the impact of those raindrops, which will in turn reduce soil erosion. We also can talk about benefits in terms of air pollution reduction. And trees do that in many ways as well. So not only are trees removing carbon dioxide from the atmosphere, but they are also absorbing nitrogen oxides and sulfur oxides and ozone from the atmosphere. And the leaf surfaces themselves are trapping particulate matter out of the air. So dust particles and dirt particles that bump into the leaves will get pulled out of suspension in the air and held within the tree, and that also helps to reduce air pollution. So again, the healthier the tree, the more leaf surface it has, and the quicker it's growing, the better it's going to be at pulling pollutants out of the air, which again benefits humans. We can also talk about energy savings. So anywhere we have a tree in close proximity to a building, that tree can help to reduce energy usage and therefore energy cost within that building through either shade or through acting as a windbreak. So for example, if there's an air conditioning unit in this house and the tree is shading that house and that air conditioner from the sun, then not only is that tree pulling existing carbon dioxide out of the air, but it is reducing the amount of carbon dioxide and other pollutants that are released into the atmosphere from the use of that air conditioner. So you have carbon absorbed, but also carbon avoided when you have trees that can shade or act as windbreaks for buildings and reduce energy usage. So if we want our trees to do all these great things for us, then they need to be able to successfully carry out photosynthesis. A healthy tree will provide more in environmental services benefits than an unhealthy tree. And we in our management can help to keep our trees healthy and therefore help them to provide us with more of these great services. So it's important to remember what a tree needs to be able to function. And for photosynthesis to happen, we know that trees need carbon dioxide from the air, they need water from the soil, and they need light from the sun. At the most basic. Trees need other things, but these are the basic components of photosynthesis. And these have implications for management. So anything that inhibits a tree's ability to carry out photosynthesis, or we could also think about that in terms of anything that prevents a tree's access to air and water, or prevents a tree's ability to move air and water, is going to harm the tree. And that is therefore going to reduce the tree's ability to provide those valuable environmental services. So if we damage a tree's root system, or if we take off too many leaves, and the tree isn't able to draw water out of the soil or carbon dioxide out of the air at the same rate that it was before we caused that damage, or before it had that insect infestation, then it's not going to be able to photosynthesize as successfully, and it's not going to provide the same amount of those benefits that we come to rely on the trees for. One of my favorite professors in college used to say that forestry is common sense elevated to a science. And that isn't to say that forestry is not complex, because it really is. But I think that there is also a beautiful simplicity to forestry and to trees. Trees make sense. If something doesn't look right or if something doesn't make sense, then it probably isn't right. So I would encourage you as you go through the rest of core training and in your tree management in your community to keep coming back to this phrase, to forestry as common sense elevated to a science, and apply that to what you see and what you do in your management. And with that, I'm going to wrap up part 1 of Trees 101, and I look forward to joining you again for part 2.